In the world of server management, monitoring the right metrics can be the difference between smooth sailing and a full-blown crisis. Today, we're diving into the vitals of server health. Let's start with CPU load trends. These give us insights into the demand and processing power over time. Next, we'll check the pulse of our system's memory to ensure our applications have the resources they need. Moving on, disk I/O operations will tell us about the read-write speeds and queues that affect data access and transfer rates. And finally, we'll look at network throughput, the artery of our server's communication. So keep your eyes filled for these metrics throughout this module. A company has noted slowness on a server and created a PowerShell script to record various performance metrics to a CSV file over time. In this demo, I will explain the PowerShell commands used in this script to monitor CPU utilization, available memory, disk latency, and network traffic. For each counter, we'll cover how to retrieve the metric with getCounter and discuss what the values indicate. Once all the counters have been covered, I'll showcase the full monitoring scripts that brings them all together. The team previously set up a script to record metrics like CPU, memory, disk, and network to a CSV file. Let's first take a look at the CSV file that it generates. You can see that the CSV file has a timestamp, a counter, and value fields. Looking at the data over time, you can see some negative trends indicating a degradation in performance. CPU usage has steadily been increasing week over week. Available memory, you can see, has also been trending downward, indicating a potential RAM constraint, and average disk latency and average disk write latency has spiked, pointing to a potential I/O bottleneck. This highlights the value of collecting historical performance data to understand and analyze trends over time. Now, let's walk through what the script is capturing exactly. First is CPU, like we did in the previous demo, so nothing special there. We'll just use getCounter and specify that same counter set name. And you see right now it's okay. Next up is available memory. Again, using getCounter, I can specify the total memory. In this case, I'm just going to use available megabytes. You can see we have 6,603, so not too bad right now. For disk, we're recording read and write latency. So for read latency, we can check for all volumes using the asterisk on the logical disk counter set, and we can use average disk set read, and we have 0 right now, so right now it's good. And then we can also check the write latency by using the write name here, and those look good as well. Now for these, if those are higher latency values indicate slower disk I/O. And for the traffic volume, we can use the network interface counter set and look for all network interfaces using the asterisk again. And this time we'll use bytes total per second. You can see right now it's doing 2,487, so about 2.4K a second, which right now is not too bad, but it's all about the trend. Now let's take a peek at what the script looks like to pull all these commands together to build this nice looking CSV file you found. Now I've tried to comment out this script the best that I can, and it will be available for download for use and to play with. The script essentially does 3 main things. First, it creates an array of each counter to query and assigns all those counter names to the counter's array variable. Next, it runs getCounter to query all those counters at once and captures the value from all of them into the counter result variable. It then loops through all of the sample values in that output, creates a custom PS object of the timestamp, the counter name, and the value, and then exports that object to a CSV file. This is a great script to add into any scheduled task run at a certain interval. It's built to be remotely too, as you can see from the invoke command reference there, and using the server name parameter that I've provided to it, you can pass different server names to it. So I'll run it manually now, and let's see what happens. I'll use PowerShell remoting to connect to the server and then run import CSV to check on the CSV file to see what the latest timestamp is. And there we go. It looks like the latest timestamp is 4:20 p.m. on 11/7/23. So it did work, and you see that it did record all of the current values. So this will be a great script to add to a scheduled tasks that runs every so often. So feel free to download and expand upon this script in your own environment.